Let's talk about flow control. The greater the range of the input data and tasks that our code works with, the more useful it is, the more automated it is. And one of the ways of making code more flexible and general is to write code that changes its behavior based on the context, which is the value of the variables or the input data. Now, changing which lines of code are run depending on the context or how many times a task is repeated is known as flow control. And there are two main ways of controlling the flow. The first is to make choices or decisions, while the second is to perform repetitive tasks. So let's start with making choices. And the syntax for making choices in R and the syntax in other programming languages is very similar. The details will change, but the same principles apply. The syntax is if, and in parentheses, you put either a Boolean variable or a statement that returns a Boolean value. And this must be a scalar Boolean, not a vector of Booleans. And after that, you have a statement. And what this does is, if this Boolean variable or the statement that returns a Boolean value is true, then this statement, true action statement, is run. On the other hand, if this condition is false, the Boolean variable is false, then the statement, true action, is not run, and you go and execute whatever comes next after the if statement. Another way of writing if statements is if the Boolean variable, the condition, is true, then the true action statement is run, and then you say else, and you put another variable, another statement, which is the false action statement. And if the condition is false, then the false action statement is run before the flow goes on to the next statement after if. So let's see how this might work in practice. And what we'll do is we'll generate two random numbers using the rnorm function. Now the rnorm function generates normally distributed numbers, that is things having a Gaussian distribution or a bell curve. N, the first argument n, specifies how many random numbers will be generated. The second argument is the mean, so the mean of those random numbers, and the third argument is st, or the standard deviation of those numbers. So we will generate two random numbers, and we will test whether the first one is greater than the second one and assign the result to a variable. And obviously, since this is a condition, this variable will be Boolean. It will be a Boolean scalar. And then we will print out this variable and use this variable in the if statement to print out greater if true. And we'll follow this if statement with another statement to print hello. Okay, so we will generate random number 1 with rnorm, and we are just going to say n equals 1, and r2 is generated by rnorm again, and the we still want a scalar. And let's create a Boolean variable gt, which tests if r1 is greater than r2, and let's print out gt. And then let's write the if conditional statement. So we'll say if gt, and follow that with the true action statement. So we'll say print greater, and the next line of code is print hello. So when I run this code, you can see that GT is a Boolean scalar, and as I said, when you're using if statements, you have to have this Boolean variable, or the statement that returns a Boolean value. It has to be a scalar value, and it was false, so it did not print greater. It skipped ahead to the code, the line that follows the if statement, and it printed hello. And we can also just print out R1 and R2 so we can see for ourselves what the values are. I run this code again. Now R1 was 1.84 and R2 was 0.04, and R1 is greater than R2, so GT had the value true, and then it printed greater, and followed by the statement that follows the if condition hello. Now let's try doing the same, but with using the if else syntax, and we are going to have basically the same code, except we will say else print lesser than or equal to. And once again, I can run this code. In this case, the first number is less than the second number, and GT is false, and so it has printed lesser than or equal to. I ran it again, same way, a third time, and this time it's greater. Now, what happens if you want to execute not one statement, but several statements if the condition is true, or several statements if the condition is false? You can do that if you enclose them within curly braces. And statements, a group of statements, and you can enclose an arbitrary number of statements between the curly braces, and they are known as compound statements. So let's try this out. And now, in addition to printing out greater, lesser than or equal to, let's also print out the absolute value of the difference between the two numbers. So now, when we write our if statement, we will say if GT and start with curly braces, and RStudio automatically puts the closing curly braces. This is helpful. Otherwise, if you start a curly brace and don't close it, then that leads to errors or bugs. And it's important. One of the big source of errors is not having matching curly braces. So one should be careful, and RStudio helps here by automatically introducing the closing curly brace. So if GT, then we will print greater, and then we also want to print the absolute value of the difference, since R1 is greater than R2. If GT is true, it means R1 is greater than R2. The absolute value will be R1 minus R2. And then after this compound statement, I'll have else, and I will add a new set of curly braces for the compound statement for the else condition. And now I will say print lesser than or equal to, and I will print now R1 is lesser than R2. Therefore, to get the absolute value, I have to subtract R1 from R2 instead of the other way around. And now we can run the statement, and in this first try, the first number is smaller, and Therefore, it prints lesser than or equal to, and it prints the absolute value. It's positive. And if our code is working right, then the absolute value should always be positive, and that is indeed the case. So it's possible to have an arbitrary number of statements run, whether the condition is true or false. We just have to write compound statements. That means multiple statements enclosed in curly braces, and these compound statements act as one statement. They act together. One unique feature of our if statements is that they actually return values. This may not be true in other programming languages. So let's try and write a statement that will take a random number generated with rnorm, and it will determine its absolute value. And so I will have a number r, and I will generate a scalar n equals 1, random number with rnorm, and an if statement to return the absolute value would be if r is greater than 0. So far, we have always put a Boolean variable in between the parentheses, but as I said before, you can also put any statement that returns a logical scalar. So this conditional statement, r greater than 0, returns a logical scalar, and we can use that instead of a Boolean variable. Then you should return r, else you should return -1 times r. And since this statement will return either r or -1 times r, I can assign this to a variable absr, and then if I wanted, I could print out this absolute value. So let's see, and let's also print out r, and you can see that it is computing the absolute value. And so this if statement actually, like a function, returns a value that can be assigned to a variable. Now that we know conditional statements, we can explore one really cool feature of functions. And we have talked about how functions can be called from anywhere, even from other functions. In fact, it's possible to call a function from within itself. So a function can call itself. And this is known as recursion, and it allows you to write some very elegant code. For example, let's say we wanted to calculate the factorial of a number, which is n times n minus 1 times n minus 2, and so on until you get to 1. We could write a function like this: my factorial function, and it will take one argument, which is the number, and we can use the return property of if to check if the number is 1, then we have reached the end, and we will just return 1, else we will return n times my factorial n minus 1. And what this will do is, let's say we start this function off with 10. 10 is not equal to 1, so it will return 10 times whatever my factorial 9 would return. So my factorial will get called again, but this time the argument is going to be 9. 9 is still not 1, so it will return 9 times whatever my factorial of 8 returns, and this will keep recursing until you call my factorial with an argument of 1, and since n is equal to 1, it will simply return 1, and it will go back up the stack until the final function returns the factorial. So now I can call this function, let's say with 5, and it returns 120, which is correct. It is also possible to test multiple conditions using else if. So let's try this out. Let's write a function that takes a student's grade in percentage and returns the letter grade. So we will have a function called letter grade, and it will take as an argument the percentage grade, and if the percentage grade is greater than 90, then return A. Else if percentage grade is greater than 80 and percentage grade is less than or equal to 90. So we are using the AND Boolean operator to combine two conditions, percentage grade greater than 80 and percentage grade less than or 90. Then return B. Now we needn't actually have checked whether percentage grade is less than or equal to 90, since percentage grade is greater than 90 is false, right? If it was true, it would already return and this statement would never be checked. Therefore, this checking whether percentage grade is less than or equal to 90 is actually redundant. And in the next one, we can leave it out. So else if percentage grade is greater than 70, then we should return C. Else if percentage grade is greater than 60, then we should return D. And last, we can just use else, return F. Let's test our function. So we'll say letter grade 76, that's a C, 70, that's a D, 90.00001 is an A, so it works. So here we are choosing from multiple alternatives, and you can use the if, else if, and else syntax to choose one among many alternatives. In a special situation where you are choosing from one among many values of a character string, then a different syntax, more convenient one, is available, known as the switch statement. And let's write a function that will compute some statistical summary like mean, median, standard deviation, and so on that we define for a given variable in the Penguin dataset. So let's call it compute Penguin summary, and this function will take summary, and let's make mean the default value of the summary. So summary is a string argument, a character string, which describes what type of statistical summary we want. Do we want mean? Do we want median? Do we want standard deviation? Or do we want mean absolute deviation, or MAD? And then we will take the name of some variable in the Penguin dataset, for example, body mass G or flipper length mm, and so on. And what we would like to do is, based on the value of summary, we would like to compute the appropriate call the appropriate function in summarize with dplyr to compute the summary for the variable. Now, first let's load Palmer Penguins quietly using require, and then we'll use the switch statement. And the first argument of the switch is a character string. In this case, it's our argument sum, and we're going to choose from one among many alternatives. So if summary happens to be mean, then we'll take the Penguins dataset and pipe it to group by, and let's say we want for each combination of species and island, we would like to know the average or the mean value of whatever variable it is. And so now we will summarize. Since we're computing the mean, we'll give the column name mean, and then we want our summary function. In this case, it's going to be mean. We have to put the variable. Now we run into a problem over here, because over here normally we would put the column name over which we want to compute the mean, but variable is not a column name. Variable is a string that contains the column name, and in this case we have to get what column it is using the get function. So if you are directly writing the column name, you just write the column name. But if the column name is data stored inside a variable, then you have to get the column name using the get function. And of course we want na.rm is true, otherwise we'll get a bunch of NAs and my parentheses are closed. And then I can just add more such options, because I'm selecting from one among many. So I could perhaps also give the user the option to compute the median instead of the mean. Then I could give the user the option of computing the standard deviation or the mean absolute deviation, which is, and of course we should name the columns appropriately. So it'll be median, it'll be SD, it'll be MAD, and here I will say MAD. Now finally, in the switch statement, the last option must be stop and handle the situation where the string, in this case contained in the variable sum, does not match any of our options. And so we will say stop, and you have to give a string in quotes wrong option. You can say whatever you want in these quotes. Okay, and then we will assign the output of the switch, what it returns, to a function, let's say summary, and now we can return the summary. And let's call this function. And let's say we want to compute the mean, and it has to be a string of the name of the variable is body mass g. This is also a string. If we run it, we get all the combination of species and islands and the mean of the body mass. I could change this variable to flipper length mm, and now it's computing the mean of the flipper length mm. I could change this to median, and now it's computing the median. And so you can see how by using the flow control statements, by making choices, we have created a function where, without rewriting this code over and over again, we can simply have a flexible function then that can do multiple different things based on the arguments we give to it.